Today we'll be going through chapter 10 and specifically lesson 10.1, adding and subtracting polynomials. Unit 10 is all about polynomials and factoring of received pieces, so this is kind of the outline of the lessons we'll be going through. Adding and subtracting today has specific rules. Next lesson we get into 10.2 will be about multiplying. 10.3 is about how to greatest common factor polynomials. And then we'll get into solving factored equations in 10.4. That will actually be moved to after we've figured out how to factor. Right, so this will be moved over here. But then we'll get into factoring x squared equations, factoring ax squared equations where we actually have a number like 2x squared or 3x squared or 4x squared. And then factoring cubic equations. So that would be of the third power equation. We may also add a lesson on how to do diamond method, right? So how diamond method works and what it looks like, so you can kind of get the pattern for how factoring will work before we jump right into it. 10.1 is about adding and subtracting polynomials again. And so what is a monomial, right? Poly means many, monomial means one. So we would consider that a number, variable, or the product of both, a number and one or more variables with whole number exponents. So we've got 3 would be a monomial, minus 2x would be a monomial, 3x squared times y would be a monomial, and half x squared. Those are all monomials. Now just to expand on the last part, whole number exponents means that those means numbers 0, 1, 2, 3, 4. So 3x to the negative 4 would not be considered a monomial, right? But 3 over x to the 4th would. Okay, that's kind of silly, but the left one would not be considered, the right one would. So when we did that chapter on exponents, that's part of the purpose. Also, they're saying that whole number exponents, so 3 squared of x would not be, right? That is a no-go for a monomial. Next, the degree of a monomial is the sum of the exponents of the variables in the monomial. So for example, that sounds like a mouthful, right? Let's do the degrees of the above, right? It's basically what the exponent of x or the variables add up to. In this expression, 3, there is 0x. So our degree is 0. Minus 2x, we have an x, and even though they don't write the exponent, it's a 1. So the degree of that monomial or term is another word we use for that, would be 1. Next, we've got 3x squared y. Well, x has 2, y has 1. And so we do 2 plus 1 to get 3 is our degree of that term. Half x squared, 2 is our degree, and so on. Right, the other ones that added, we're not going to do there. So what is a polynomial, right? Typically, it's a sum of monomials, right? So we have more than one monomial. The standard form that we're going to be looking at for quadratics, again, but notice, what do we have here? We've got ax squared bx plus c. The number of our degrees goes down, right? This is degree 2. We've got x to the 1. We've got no x, right? So standard form is to have the degrees from from greatest to least. Right? Greatest to least in terms of degree. Okay. And then lastly, degree of polynomial, again, just kind of well, now we've got a monomial, what about a polynomial? We're only looking at the largest exponent. So if you look at this term again, ax squared, that has the largest out of plus bx plus c. So the degree of that one would be 2. And how do you determine that? Just list the degree of each piece. The largest number is 2. Therefore, the degree is that largest number. To add and subtract polynomials, we're simply combining like terms. Very straightforward, very simple, right? But you have to know what are like terms. We've done this before, but it was when we did it before, we did it with x's and y's. We didn't do it with squared. So like terms have the same variable and the same exponent. So in this list below, we're going to identify the like terms, and we're going to say, let's circle the ones that are like, and if the ones that are different but also like, we're going to box So negative 3x squared. Right, I've got an x squared here. We're looking for any others that have x squared. Here's another one, x squared. We skipped 4xy squared. We skipped 5y squared because y is different than x. And so these two, 7x squared minus 3x squared, are like terms. Now looking at what we have left, xy squared here, y squared here, x squared, y there. Neither of those are like because this has x to the 1, y2, and this one on the end is x2, y1. Flip them. So the rest of them are not like terms, right? Just negative 3x squared and 7x squared. So one more time, like terms, we've got x, 5y squared, 2xy, minus 6y squared, and 9xy. Now, just reading it out loud, I kind of, which one did I repeat is kind of per se, right? So no, nothing else at just x, so we're going to knock that one. That first one doesn't have a match. Next, going to 5y squared. Okay, do we have anything else with a y squared? Up right here, just y squared. So these, I'm going to box these, are like terms. 5y squared and minus 6y squared are like terms. Now what's left? We already went through x on the left, right? We've got 2xy, 9xy. I had a repeat. Those are also like terms. However, since they are different than the y squareds, I'm going to circle those because those are like terms, but they are not like to the box ones, right? It's 5y squared and minus 6y squared, those are like, and 2xy and 9xy are like without being like the y squared, okay? To add and subtract, moving on. You add the coefficients of like terms. So let's say we were adding or subtracting this top piece just for one moment here. Okay? As our example below, we have 5x plus 3x. They both have x. And so we would add, what's 5 plus 3 is 8. That's where that 8 came from. That 8 came from 5 plus 3. What if we were subtracting, right? What if we had 4x squared minus 6x squared? The x squareds match, so we do the 4 minus 6. That's technically what we're doing, distributing, but backwards. And then 4 minus 6 is minus 2. And so what do you know? Our answer is minus 2, and the x squared was still there, minus 2x squared. Now up top, if we're doing the same thing, x was by itself, so we still have x. The 5y squared minus 6y squared becomes 5 minus 6 y squared. 5 minus 6, sorry for spacing here, 5 minus 6 is negative 1, so this would be minus 1 times y squared, or just a minus y squared. And then lastly, 2xy and 9xy, they both have the xy, so you kind of take the xy's out, what's 9 plus 2, and we get 11xy. So if we added all those pieces up top together, we would get x squared minus y squared plus 11xy. Now for some examples, right? Adding and subtracting, we're going to simplify. Okay, we've got x cubed plus 7x squared minus 12x. And again, notice how the degrees are going down. We had 3, we had 2, we had 1. It is possible for a degree to be skipped. So for the next one, plus 3x cubed plus 9x minus 8, right? So that was the degree of 1, right? We jumped, we skipped 2 here. There was no 2, there was 0x squared, right? So when there's 0x squared, it just didn't get written. It's because you wouldn't write 0x squared every time that appeared. So here's how you add. We're going to rewrite the right polynomial, put them in parentheses. We're going to rewrite that one underneath the ones they match in the left side. So the degree and the variables need to match. So I'm going to write 3x cubed here because they're both x cubed. So this will be my x cubed column. Next, I've got 9x. I don't have a 9x over here, so I'm going to kind of put it in its own column. We'll make a column right here, 9x. Try to keep that minus sign still visible here. Because 9x, it's a plus, is on its own. And then lastly, we have minus 8. Sorry, on that one, we actually have, 1, 1 matches. We have plus 9x will go right there. We don't have a column for the last part. So because they were both degree 1 of x, we're going to add those together. We did not have any x squared. So we weren't going to put anything there. And now minus 8 goes right here. Sorry, looks like a double negative, but minus 8, again, doesn't have anything to add to. And now we're adding, what is 1 plus 3? 4x cubed. What is 7x squared? Just comes down. Now I got minus 12 plus 9. 9 is smaller, so we take the larger number sign. 12 is negative. And then 12 minus 9 is 3 to get minus 3x. And then the minus 8 just comes right down. And that is simply how we are going to add or subtract our monomials. Okay. Next one. It looks like they got longer here, right? It looks like we now have more pieces. I count 4 in this first piece. It is probably a good advice to write the degrees over the top so that we don't make a mistake I was kind of doing in the last one where I was adding two that did not have the same degree, right? We have 4, 3, 2, 1x, 0. So the right side 4, 3, 2, 1, 0, left side 5, 3, 2, 0. So then again, it's a plus sign, so we're just adding. So 8x to the fourth is going to kind of be between these two columns, 8x to the fourth, because there is no other x to the fourth, right? If you're looking at our numbers, the 4 is unique, the 5 is unique in this question. Next, so that one's done. It's minus 7x cubed, rewriting it under the x cubed column, because those will add together. All right, kind of a little crooked there. And then plus 3x squared. We do have an x squared column, right? 2 and 2. So writing it underneath the 10x. Minus 10x, right? We don't have a spot for that, so I'm just going to kind of put that right in between those, minus 10x. And then plus 7, which does go underneath the 12. Okay. So that 1 and the 5 were, and 4 were ones that did not have a match. That little bit circle. Now adding 2x to the 5th, right there, 2x to the 5th by itself, plus 8x to the 4th by itself. And now we're adding our columns, minus 3, minus 7. If I owe 3 and I owe 7, I'm going to owe 10, and then you bring the x cubed with. 10x squared plus 3x squared, 10 plus 3 is 13, and the x squared comes with. Now again, notice we've got 5, 4, 3, 2, right? We're going to actually count all these down, minus 10 to the x, that's just going to come straight down. And then our last computation, so that was 1, now we got 0. 12 plus 7, but it's a negative 12. 12 is bigger than 7, so it will be a minus, and then 12 minus 7 is 5, and there is our polynomial answer to that sum problem. Now we'll also run into a subtraction problem in a little bit, and that's literally one sign change difference than what else. So one more set, 3x to the 4th, 5x squared, 10x minus 5. Notice we're missing the cube section. And now over here, plus 8x cubed minus 10x squared plus 9x. So rewriting this, I'm going to rewrite as if this is a homework problem. Right? Rewriting the first one, 3x to the 4th. We're going to leave a gap for the x cubed, minus 5x squared, plus 10x, minus 5. And then we're adding this one underneath. So 8x cubed is going to go here. We're kind of counting down, right? This was our 4s, this was our 3s, second degree, first degree, 0 degree. So that's why 8x cubed is under a blank right here, right? We got our columns, minus 10x squared underneath the 5x squared of negative, plus 9x under the 10x, and then there's nothing under the minus 5. So now bringing down anything that didn't have an adding, so we got 3x to the 4th, 8x cubed, and now minus 10 minus 5 is minus 15, x squared, 10 plus 9, 19x, there's a plus, and then minus 5 just comes straight down. And there's our resulting polynomial. Easy as adding. Notice none of the times did my exponents change, right? When we have, for example, these x squared as our like terms, it didn't become x squared plus x squared gives us x to the 4th, right? Because you kind of just view those variables, each set, even with the degree, is a different item, right? Like x to the 4th would be cats, x to the 3rd would be dogs, x squared would be hamsters, x would be rats, and maybe the minus 5 is cans of food, right? They're different things, so they aren't changed by adding themselves together, right? Dogs plus dogs don't equal cats. Okay. Next one, notice there's a subtraction sign. So here's how subtraction works. I'm going to rewrite this first one, 5x cubed minus 8x squared. Now notice we're counting down 3, 2 degrees, right? What the exponent is. 3, 2. I have 0, 1, so I'm going to leave like a blank here. That's a spot for the 1 degree of 1, and then plus 23. And now I'm going to rewrite the second one underneath. However, it's not just minus 2x cubed. It's minus all of these. So this negative sign is going to flip every single sign. It's like -1 times the whole thing, and we're adding. So I'm going to rewrite all these in the correct column, right? This is 3, 2, 1, 0 for degrees, but I'm going to switch the sign. So instead of plus 2x cubed over here, I'm going to write minus 2x cubed. And it was minus because the opposite of plus is minus, right? That's simply what it is. The next one, now we got a minus 9x, but it's already minus, so we're going to flip the sign to plus, right? Double negative, sorry, x squared, by the way. And we're going to end up with a plus, right there, plus 9x squared. Next, a opposite of plus 12x is minus 12x, and the opposite of plus 15 is minus 15. And then we're at the same spot we were before with adding. 5 minus 2 is 3. Negative 8 plus 9, 9 is bigger, so it's positive. 9 minus 8 is 1. Minus 12x just comes down. 23 minus 15 is plus 8. And that is as simple as subtraction is going to be. We'll do 2 more examples and call it good. So again, writing our degrees out, 2, 1, 0. Notice my subtraction is a third and a first. So I'm going to leave a blank. There's for 3's, and we got 2x squared for plus, minus 7x, and plus 12. And now when I flip the sign, minus x cubed, that goes in the first column. These were like third degree, second degree, first, 0. And then minus 7x, and that's going to go in the first degree. So minus 7x there, right? Opposite of plus 7, and then subtraction. Now, sorry, adding. We flip the sign, we're adding. So we're not double subtract. Minus 7 is minus 14x, and we really only have one calculation we need to do there, and that was the minus 7. Everything else was by itself. So pretty short and sweet. Negative x cubed plus 2x squared minus 14x plus 12. One last one. Now notice 5. We're getting pretty high numbers for degrees. We got 4, 3, 2, 0. And so we're going to write out blanks for each one we have. So we got 5x to the 5th. I have a blank for the 4th power. We got minus 12x cubed for the 3rd, plus 10x squared for the 2nd. I have 0, 1, right? There's no 1 here, and there's no 1, like, first power there either. So technically, I can just leave a gap. There is no 1, so I'm just not going to write a 1. We're going to make minus 5, so this is going to be our, like, 0 or our constant right there. And now I'm distributing the negative, right? So distributing the negative sounds fancy, but we're just flipping signs. So opposite of 9x fourth, minus 9x to the fourth. Opposite of minus 10x cubed, plus 10x cubed. Opposite of plus 15x squared, minus 15x squared. Opposite of minus 7 is going to be plus 7. 5x to the 5th, minus 9x fourth, minus 2x cubed, minus 5x squared, plus 2. If you have any questions, feel free to shoot me an email. I will gladly cover those when we get to our first class meeting over Zoom.